Many people associate persistent fatigue with a lack of sleep, but the biological reality is often more complex. The body's energy regulation is an intricate system, and when feelings of tiredness become chronic, it can point to underlying patterns that go beyond a single night's rest. Understanding these patterns involves looking at how the body produces, stores, and uses energy on a cellular level. It's a process influenced by a wide range of physiological factors that operate continuously in the background of daily life. One of the foundational elements of energy production is metabolism. The basal metabolic rate, or the energy the body uses at rest, accounts for a significant portion of daily energy expenditure. As people age, this rate naturally tends to decline. This change is partly due to a gradual decrease in muscle mass and an increase in fat mass, as muscle tissue is more metabolically active than fat tissue. A slower metabolism means the body burns fewer calories at rest, which can affect overall energy levels and how efficiently fuel is converted into usable power. This is a normal part of the aging process observed across populations. Another key aspect is hormonal balance. Hormones act as chemical messengers that regulate numerous bodily functions, including metabolism and energy. The thyroid gland, for example, produces hormones that are critical for controlling how the body uses energy. If thyroid hormone production is suboptimal, it can slow down many bodily processes, leading to feelings of sluggishness and fatigue. Similarly, cortisol, a hormone produced by the adrenal glands, plays a vital role in the body's stress response and energy management. Normally, cortisol levels are highest in the morning to help with waking and gradually decrease throughout the day. Disruptions to this natural rhythm, often linked to chronic stress, can interfere with energy cycles and sleep quality, creating a persistent state of tiredness. Cellular energy production itself is centered in the mitochondria, often called the powerhouses of the cell. These tiny organelles convert nutrients from food into adenosine triphosphate, or ATP, the main energy currency of the body. The efficiency of mitochondria can decline with age, a phenomenon known as mitochondrial dysfunction. This means that even with adequate fuel, the cells may not be able to produce energy as effectively as they once did. The cumulative effect of less efficient mitochondria across trillions of cells can manifest as a noticeable decrease in overall physical and mental stamina. This process is a subject of extensive research in the field of aging. Nutrient intake also plays a direct role. The body requires a steady supply of macronutrients, carbohydrates, proteins, and fats, as well as micronutrients like vitamins and minerals to function properly. For example, B vitamins are essential cofactors in the metabolic pathways that convert food into energy. Iron is a crucial component of hemoglobin, the protein in red blood cells that transports oxygen to tissues. Without sufficient oxygen, cells cannot produce energy efficiently, leading to fatigue. Inadequate intake or poor absorption of these vital nutrients can therefore directly impair the body's energy production capacity. Physical activity habits have a significant impact on energy levels, though the relationship can seem paradoxical. While intense exercise temporarily depletes energy, regular moderate physical activity can increase energy over the long term. This is because consistent movement stimulates the body to produce more mitochondria and improve circulation. Better circulation ensures that oxygen and nutrients are delivered more efficiently to the muscles and brain. Conversely, a sedentary lifestyle can lead to deconditioning, where the body becomes less efficient at producing and using energy, making even simple tasks feel more exhausting. The quality of sleep is as important as the quantity. The body performs critical repair and restoration functions during deep sleep. It consolidates memories, clears metabolic waste from the brain, and regulates hormones related to appetite and stress. When sleep is frequently interrupted or fails to reach the deeper, more restorative stages, these processes are disrupted. A person might spend 8 hours in bed but wake up feeling unrefreshed because their sleep architecture was poor. This lack of restorative sleep can lead to significant daytime fatigue and a feeling that one's energy reserves are never fully replenished. Hydration status is another often overlooked factor. Water is involved in almost every biological function, including nutrient transport and energy production. Even mild dehydration can thicken the blood, forcing the heart to work harder to pump it through the body. This increased effort can cause fatigue. Dehydration can also slow down enzymatic activity, further hampering the metabolic processes that generate energy. Since the sensation of thirst often diminishes with age, older adults may be particularly susceptible to the fatiguing effects of inadequate fluid intake. Chronic low-grade inflammation is another physiological state linked to persistent tiredness. Inflammation is a natural immune response, but when it becomes chronic, it can interfere with normal bodily functions. The immune system's constant state of activation consumes a significant amount of energy and resources. The chemical messengers of inflammation, known as cytokines, can also directly affect the brain and central nervous system, contributing to feelings of fatigue, malaise, and a lack of motivation. A condition sometimes referred to as sickness behavior. Mental and emotional states are also deeply intertwined with physical energy. Sustained psychological stress, for instance, keeps the body in a state of high alert. This fight-or-flight response is energy-intensive, diverting resources away from other functions like digestion and repair. Over time, the constant demand on the body's stress response system can deplete energy reserves, leading to burnout and exhaustion. The brain itself is a major consumer of energy, and periods of intense concentration, worry, or emotional distress can be just as draining as physical exertion. In summary, the feeling of perpetually low energy is rarely attributable to a single cause. It often emerges from a combination of interconnected factors. These include natural changes in metabolism and mitochondrial function associated with aging, shifts in hormonal balance, the quality of nutrition and hydration, and the regularity of physical activity. The restorative power of sleep, the presence of chronic inflammation, and the physiological impact of psychological stress also play crucial roles. The body's energy system is a dynamic and complex network, and a sustained decline in energy often reflects a broad disruption across multiple aspects of its normal operation. Understanding these individual components and how they interact provides a more complete picture of why energy levels may not always rebound as expected.